Welcome to MBA Classroom. In this video, we are going to discuss PERT, Program Evaluation and Review Technique. It is a project management technique similar to critical path method, but a little different from critical path method. Critical path method is a deterministic tool, whereas PERT is a probabilistic tool. Deterministic in the sense the activity duration of the project, if there are n number of activities in a project, we know exactly the time of completion of each activity. Take for example a manufacturing company which is manufacturing car dashboard, and the processes involved from getting the raw materials, storing it in inventory, taking the particular raw material to the production area, and maybe filling the plastic material in the mold. Everything we know exactly the time of completion of each activity. So that is why CPM is called as a deterministic tool, whereas PERT is a probabilistic tool which is applied for projects which are new. For example, building a house, a satellite project, or any new project, cinema, direction of a cinema, which are all new. We don't know exactly the time of completion of each activity. So to find that particular time duration, we are going to consider three estimates: optimistic time, pessimistic time, and most likely time. Optimistic time is the minimum time of completion of an activity without any problems, without any interruptions to the activity. It is like ideal situation where the activity is going on as per plans. The second one is a pessimistic time. It is the time, or it is the maximum time of completion of an activity wherein all interruptions happen, all unplanned interruptions happen. That is pessimistic time. And the third one is most likely time, which is the time of completion of activities which are similar in nature. Maybe there is a similar activity somewhere else in another project, and we are going to take up that particular activity duration. So that is the most likely time. And with these three estimates, we are going to calculate the time of completion of an activity using this mean formula. Mu is equal to TO plus 4TM plus TP divided by 6. And if you look at the formula, you can see that the most likely time gets 4 times importance than the optimistic time and the pessimistic time. And PERT is a special case when compared to CPM, in the sense we can find the probability of completing a particular project. To find the probability of completing the project, we need variance of the whole activity, variance of each activity, and from that variance we are going to find the standard deviation, which we are going to apply in the formula to find the probability of completion of the particular project. And now we are going to discuss PERT with an example, with a problem which has got 6 questions. The first one is construct project network. Second one is find the expected duration and variance of each activity. Find the critical path and expected project completion time. Determine the probability of completing the project in 25 weeks. Determine the probability of completing the project in 15 weeks. Determine the scheduled completion time if the probability of completion is 0.8. So among the 6, the first 3 resemble a critical path question, critical path method question. All 3 are, if we solve all 3 the questions, we will get the solution for a critical path network. Whereas 4, 5, 6 are special to PERT. That is what we are going to discuss in this particular video. And this is the data given in the problem. There are 11 activities A to K, and the predecessor relationship is also given, and the 3 time estimates A, M, B. A is the optimistic time, M is the most likely time, and B is the pessimistic time. All 3 estimates are given for each activity. So now we are going to calculate the mean of optimistic, most likely, and pessimistic time for each activity, and the formula which we are going to use is this mean formula, TO plus 4TM plus TP divided by 6. So these are the values. TO is 6, TM is 7, and TP is 8 for this A activity. So 4 into 7 is 28, plus 6 is 34, plus 8 is 42, and divided by 6 is 42 divided by 6 is 7. So for activity A, the mean time of completion of that activity is 7. Similarly, we are going to find the activity duration for B. B is 2 into 4, 8, 8 plus 1, 9, 9 plus 9 is 18, 18 divided by 6 is 3. So the time of completion of this activity B is 3. Similarly, we are going to calculate the time of completion of each activity from C to K using this formula, and we are going to arrive at the values. Now, to find the probability, we are going to find the variance of each activity. Variance of each activity, the formula is sigma square is equal to TP minus TO divided by 6 the whole square. So TP for A is 8, and TO for A is 6. So 8 minus 6 is 2 divided by 6. 2 by 6 is 1 by 3. 1 by 3 square is 0.11. So 0.11 is the variance for A. Similarly, 9 minus 1, 8, 8 divided by 6 is 2 by 6, sorry, 4 by, 9 minus 1 is 8, 8 divided by 6 is 4 by 3. 4 by 3 is 1.33, 1.33 square is 1.78. So, likewise, we are going to calculate the variance for all the activities, and this is the second step in the PERT problem. First is calculation of mean, second is the calculation of the variance, and now we are going to construct the network. So after finding the duration of each activity, we are going to construct the network and find the critical path. Critical path is our third question, which we are going to solve now. So for that we need this activity and the predecessor relationship. As you see on the screen, there are 3 activities A, B, C without any predecessor. In that case, all 3 activities are the starting activities. There are no predecessor, so they are the starting activities of the project. So the project starts simultaneously. A, B and C starts, and project starting node is 1, taken as 1, and A takes 7 maybe a time period, days or weeks or minutes, 7 weeks to complete, and that particular activity ends at node 2, and B activity takes 3 time period and it ends in node 3, and C takes 4 and it ends in 4th node. Now the next activity D, for that the predecessor is A. In that case, what does that mean is D starts from the node where A ends. So the node 2 is the node where A ends. So from node 2 we are going to start D. So D starts from node 2 at the end of A. And the next activity E, for E there are 2 predecessors, A and B. So we have to start E from the node where A and B ends. But in our case, if you look at these nodes, A is ending in a particular node and B is ending in a particular node. And for E, we want these two nodes to be the same. But we cannot have that because it is rule violation. The rule says no activity will start from the same node and end in the same node. So, what we can do is we can involve a dummy in this particular between these nodes. If we are having a dummy between these nodes, it says 2 and 3 are, the relationship is given, 2 and 3 are same, but there is a dummy between that. And to have the dummy, we need to point the dummy towards either second node or the third node. If we are pointing the dummy towards this particular node, what will happen? From A at this node, A ends and B ends through this dummy at this node. So, in this node, both A and B ends. But in our problem, it is given that for D, only A is the predecessor. So, we cannot have the direction of this dummy in this way. And now, we will consider the direction of the dummy, the opposite direction. When we have the dummy this way, when we have the dummy this way, right? So, when we have this one, at the node 3, B is getting over, and through this dummy, A is also getting over. So, that is perfectly alright. So, we can have the next activity E starting from node 3. Simple. And the next activity is F. F starts from C. And there is one more activity G. G is also starting from C. So, there are two activities. F and G starting from C. And again, the next activity H and I starts from the node where E and F ends. So, at node 5, both E and F ends. So, we have to start H and I from this particular node. So, H is also starting from 5 and I is also starting from 5. And the next is J. J starts from the node where D and H ends. So, at node 6, D and H ends. So, we have to start this particular activity J when D and H are over. So, J starts from node 6 and K starts when G and I gets over. So, node 7. So, K starts from node 7. And one more thing in this particular construction of network is we are going to have one starting node and one ending node. Here in this problem, if we are not given with any other detail other than J and K, we cannot leave J as end of J as one node and K as another node because the rule says there is only one end of the project. So, we are going to connect J and K to the end of the project node, which is 8. So, this is the network which need to be constructed, and the next process is to find the critical path. We need to calculate the earliest start time of each activity in the node, earliest start time and latest finish time of each activity in the nodes. So, earliest start time, we are having a small thing like a forward pass and backward pass. When we are going to find the earliest start time, we have to move forward from the starting node to the ending node of the project. And in forward pass, we are going to just add the activity duration to the earliest start time of the nodes. And if it is a single activity, we will straight away add the activity duration. But when there is a need for comparison, when two or more activities end in a particular node, what to do? We are going to take the maximum value. Okay, that is forward pass. And to find the latest finish time, we are going to move backwards from the last node, end node, to the first node, start node. So backward pass. In the backward pass, we are going to subtract the activity duration in each node, and when there is need for comparison, we are going to select the minimum value. Sorry, it is given as maximum value, but it is the minimum value which we are going to select. And after moving forward and backward, which is the critical path? The activity path where earliest start time and latest finish time of nodes are equal. So when the earliest start time and latest finish time are equal for a particular node, through that node the critical path is going, right? So we'll discuss that in the next slide. So we are first moving forward pass. We are going to calculate the earliest start time. I have given earliest start time in the denominator part, and the earliest start time of the starting node is 0. And looking at the node 2, the earliest start time of node 2 is 0 plus 7, because there is only one activity ending at this particular node. There is no other activity, so we are just going to add the activity duration with the earliest start time of the previous node. So 0 plus 7 is the earliest start time of this particular node. And the next is 3. Third node, there are two arrows, two activities end in this particular node. One is through this dummy, the activity A is ending. So 7, because dummy has got no time duration. Time duration of dummy is 0. So 7 plus 0 is 7. And 3. So we are going to compare 3 and 7. When we are moving forward, we are going to take the maximum value. So we are going to take the maximum value, which is 7. And in the fourth node, there is only one activity ending. So straight away we can add the earliest start time of the previous activity and with the duration of the activity C. So 0 plus 4 is 4. And in the node 5, we have two activities ending, E and F. E and F, the earliest start time of third node is 7, and 7 plus duration of E is 3, so 10. Or earliest start time of the previous node 4 is 4, and F duration is 5, so 4 plus 5, 9. 10 and 9 comparing, we are going to take the maximum value, which is 10. And for the sixth node, we have again two activities ending through D and through H. When we go through D, 7 is the earliest start time of the previous node. 7 plus 2, 9, or 10 plus 4, 14. So maximum value 14. Here in the node 7, we are going to take 10 plus 5, 15, or 4 plus 3 through G, 7. So 15 is the largest value, so 15. And in the ending node, we have two paths. Sixth node 14, earliest start time is 14. 14 plus 6 is 20. Or 7th node, earliest start time 15 plus 3, 18. So comparing 20 and 18, which is larger, 20. So we are going to take the earliest start time of the end node is 20. So project completion time is 20 weeks. And to find the critical path, we need to move backwards also. So when we move backward, we are going to subtract the activity duration from the previous node latest finish time. So end node latest finish time is going to be the project completion time, which is 20. And when we move backwards, 7th node, 20 minus, because there is only one arrow tail, only one arrow tail, so straight away we can subtract the project completion time, the latest finish time of end node and the case duration. So 20 minus 3 is 17. And for node 6, only one arrow tail, so straight away 20 minus 6 is 14. And in node 5, there are two arrow tails, one is through 6 and the other one is through 7. So when we go through 6, 14 minus 4 is 10, and when we go through 7, 17 minus 5 is 12. So when we move backwards, we are going to take the minimum value. So 10 and 12, 10 is the minimum value, so we are going to take 10. And in the next node 4, there are two arrow tails, one through 5 and the other one through 7. So 10 minus 5, 5, or 17 minus 3, 14. So minimum value is 5. In the next node 3, there is only one arrow tail. So 10, the latest finish time of node 5, 10 minus 3 is 7. And the next node 2, the dummy has got no duration, so 7 minus 0 is 7. And finally at the start node there are 3 activities, A, B and C. So 7 minus A's duration 7, 0, or 7 minus B's duration 3, 4, or 5 minus 4 C's duration 4, 1. So 0, 4 and 1, which is smaller, 0. So we are going to take the latest finish time of the first node as 0. Now when we look at the critical nodes, the latest start time and earliest start time are equal in some nodes, like node 1, node 2, node 3, node 5, node 6 and node 8. So the activities passing through these nodes 1, 2, 3, 5, 6, 8, these are the activities which are critical activities. So which are the critical activities? A, dummy, E, H, J. A, dummy, E, H, J is the critical activity, critical path, and it can also be denoted in terms of nodes 1, 2, 3, 5, 6, 8. So our third question is also over. So we have found out the critical path. Now the fourth question is, we are going to find the probability of completing the project. So the fourth question is, find the probability of completing the project within 25 weeks. So we are going to have a scheduled completion time as 25 weeks, whereas in the when we determine the critical path, we just now identified that the estimated completion time is 20 weeks. The scheduled time is 25 weeks. So we are going to find the probability of completing the project with these data, 25 weeks, 20 weeks, and one more data we require is the standard deviation. Standard deviation we cannot straight away calculate using the variance of all the activities. Rather, we have to take the variance of those activities which are critical in nature. Critical path activities variances is only taken for calculation of the standard deviation. So the critical path is A, dummy, E, H, J. The variance of A is 0.11, dummy has got no duration, so 0, and E 1.78, H is 0 and J is 4. These are the values which we have calculated at the first step itself. And the total variance is 0.11 plus 1.78 plus 4 is 5.89, and when we take a square root of the total variance, we get a value of 2.43, which is the standard deviation of the critical activities. Now we are going to use this normal curve table. We'll check how to use this normal curve table when we move to the next slide. See, the Z formula is Ts minus Te divided by sigma. Ts is the scheduled time, Te is the estimated time of completion of the project divided by standard deviation. So Ts we know it is 25, it is given in the problem. Te is the value which we have calculated 20, and just now we calculated the standard deviation which is 2.43. So calculating Z is equal to plus 2.06. So this is the Z value. We are going to find the area under this curve, normal curve for this Z value 2.06. So here we are having 2.0, that is 2, and this is 0.00, 0.01, 0.02. So 2.06 is, this is 2 and this is 0.06. So the value corresponding to these two, the intersection point is the corresponding value for z is equal to plus 2.06, which is 0.9803. So 0.9803 is the area under the z value 2.06, or in other words we can say 98.3% of probability of completing the project within 25 weeks. So the fifth question is also solved. Now the fourth question is solved. Now the fifth is the same process, but the schedule time is given as 15 weeks. Now the schedule time is 15 weeks. Same way we are going to calculate the z value. Here it was previously it was 25, now it is 15. So 15 minus 20 divided by 2.43, which is minus 2.06. So same value 2.06, but the sign is minus sign. So what we have to do is the other thing is, one more information is, when the scheduled time is less than this estimated time of completion of the project, we have to subtract the area under the curve value from 1. When it is more than this scheduled time is more than this estimated time, there is no problem. Straight away we can take the probability as the same value. But when the scheduled time is less than estimated time, we have to subtract the value from 1. So 1 minus 0.9803 is 0.0197, or in other words, the probability of completing the project within 15 weeks is just 1.97%. So the fifth question is also solved. Now for the sixth question, we are given with the probability. The probability is 0.8. Now we are going to find out the scheduled time of completion. TS we need to find, right, with the probability, just interchanging the values and finding the scheduled time of completion. So 0.8 is our value. 0.8 is our value. So we are going to check a value nearer to 0.8. Here it is 0.8023 and here it is a lesser value. Here it is 0.7995. So this is the value which we need. This is the area under the curve value 0.8. Now we are going to determine the z value. Z value is 0.8 and here it is 0.04. So z value is 0.84. So now we have all the values: z value, standard deviation value, we have the estimated time value. So applying all these values, we can find the scheduled time as 22 weeks. So when we need to have a probability of completion of the project as 80%, the scheduled time should be 22 weeks. So this is all about PERT. So the speciality of PERT is the probability of completion of the project, and we have seen how to calculate the probability, and in the next class we will talk about critical path method. Thank you.